Good morning friends. We'll solve one more problem today. So you just see the question paper of June July 2019. So see 10th A 10th B both are on the nozzle only. What is critical pressure ratio? Derive expression for pressure ratio which gives the maximum discharge through the nozzle. That is what we have to derive. Critical pressure ratio derivation we need to derive, and it is asked for 10 marks. Here one more problem he has given, very simple problem. Just take the problem. The steam expands from 3 bar to 1 bar in a nozzle. The initial velocity of the initial velocity is 90 meters per second and initial temperature is 150 degrees Celsius. Determine the exit velocity of the steam. If exit velocity for two conditions, one is if expansion is isentropic in nozzle, second one is the nozzle efficiency is 95%. I don't know, he has asked very simple problem for 10 marks. Just we will note down the problem now. Note down the given data. I have read already problem. The given data is the steam expands from 3 bar to 1 bar, means it is given as P1 is equal to 1 bar and P2 is equal to P1 is 3 bar and P2 is 1 bar, right. The initial velocity is given V1 is equal to 90 meters per second and temperature T1 is equal to 150 degree Celsius. He has asked, first one what he has asked, he has asked V2 using isentropic expansion and second case he has asked again V2, he has asked using actual expansion because velocity of nozzle is given as that is 95%, right. So now I'll just draw the Moliere chart. It is very simple problem. HS, right. So just draw the saturation line as usual. We are drawing saturation line. This is HS diagram. Now what is he has given 3 bar and 150 degree Celsius. Already has given 3 bar and 150. Somewhere 3 bar you just identify, 150 degree also you identify. Somewhere 3 bar will be getting here, 150 degree here. See, just I am drawing this one with my own judgment. At actually should draw it a Moliere chart. So this is 0.1. We'll get the value at this as H1. Don't calculate anything Vz1 or x1, anything. Nothing is required here. Second, it is expanded to 1 bar. Somewhere here 1 bar. Right. Just expand this to 1 bar. It will become 0.2 and here you take this as H2. Right. So now we know the formula. From this you can note down the H1 value and H2 value. So here you just note down kilojoules per kg and kilojoules per kg. So we know this formula, V2 is equal to what? 44.72 root of H1 minus H2. So you will get the value directly meter per second. Second, this one he has asked is actual expansion where there is N is equal to 95. We know that formula, efficiency of nozzle is equal to actual enthalpy drop to the isentropic enthalpy drop. Right. So it is actual, this is isentropic enthalpy drop. It is 100%. I will consider somewhere 0.95, since I will consider here it has 0.2 has reached here, 0.2 dash, right? But I don't know where it has reached, right? This is h2 dash in the this one. Like this, it is graphical representation. Now he has given you efficiency 0.95. So actual enthalpy drop is how much? H1 minus H2 dash, and this one is this one value is H1 minus H2. So these values already you know this. I can take this as small h1 and h2. So this h1 minus h2 already you have these values. So h1 minus h2 dash is equal to 0.95 into h1 minus h2. So here you will get h1 minus h2 dash. This whatever this you are calculating, it is actual enthalpy drop. Whatever here you have calculated h1 minus h2, it is isentropic enthalpy drop. So here also he has asked, using this 0.95 as a nozzle efficiency, what is the velocity. So directly I will write the velocity. V2 dash shall I take for this? I will take V2 dash for this. So V2 dash is equal to 44.72 root of H1 minus H2 dash. So H1 minus H2 dash value already we have here. Substitute this. Don't try to find out H2 dash again, because if you find out that is also okay, it will become lengthy, because directly I want H1 minus H2 dash. Take that directly value and substitute it here, you will get meter per second. So this much problem if you are solving, you are getting 10 marks, right? So this is 10 marks problem in July 2019 he has asked. So don't leave these problems. So all the 3 question paper, this one I have solved. 2 more problem I will solve, and I will end the problem solving sessions. Thank you.